Welcome to the deep dive. Today, we're tackling a big one, maybe the most successful yet, well, conceptually tricky scientific idea of the last 100 years. General Relativity, GR.
Absolutely. GR is, the foundation for modern cosmology. It makes these incredible predictions, bending star-like gravitational waves. It definitely works.
Exactly. But here's our mission for this deep dive. We're not really asking if it works. We want to know how it keeps surviving all this scrutiny, especially in areas where the fundamental physics, the causal mechanics, seem to be missing.
Right. Why does a theory with so many unanswered physical questions still hold sway?
Yeah.
And that endurance, as our sources suggest, seems rooted in a really robust set of intellectual habits, almost like a collection of survival strategies, you could say, ways to manage physical paradoxes using math or philosophical reframing.
So we're going to expose how these open problems have been sort of managed, maybe swept under the rug a bit, instead of being solved with a clear mechanism.
Precisely. We want to walk you through the key strategies that shield GR, and hopefully you'll have some aha moments about the huge gap between a math description that fits the data and a physical mechanism that actually explains why the data is what it is.
Okay, let's dive in. First up, this idea of the coordinate trick.
Right. So let's start with how GR handles contradictions we, experience every day. GR is all about the geometry of space-time, its main move to say physical inconsistencies aren't real problems, they're just artifacts of how you're looking at it, your frame of reference.
Okay, give us that classic example. Standing on Earth, feeling your own weight. In GR terms, that feeling isn't really gravity pulling you down, is it?
Correct. GR actually insists that if you're just standing still on the ground, you're essentially force-free. It's the ground in your frame that's accelerating upward, pushing you.
Wait, hold on. That feels wrong. If the ground is accelerating up at every single point on a sphere, wouldn't the Earth have to be constantly expanding, accelerating away from its own center? That just sounds physically impossible.
Exactly. That's the logical pinch point. And that's precisely where this coordinate trick gets deployed. GR uses that apparent absurdity, the expanding Earth idea, to label the whole thing as just an effect of your local coordinates, a coordinate effect.
So by changing the label, you sidestep the need for a physical mechanism. Like, what's actually causing the force you feel when you stub your toe?
You got it. The physics questions sort of get sidelined. And you see this pattern repeated, especially in more extreme situations, right? Like near black holes.
Right, the event horizon. The math goes haywire there, spits out infinities.
Yeah, those pathologies, the singularity, they're mathematical black holes, literally.
Yeah.
So to smooth things over, physicists can just swap coordinate systems, like using Eddington-Finkelstein coordinates, for instance.
And what does that actually do for us, the listeners?
Well, picking that specific mathematical viewpoint makes the infinity, the mathematical break, just vanish. Poof. Gone from the equations.
On paper.
On paper, yes. It lets the math flow smoothly across that boundary. But physically, we're still left wondering, what actually stops a total collapse? What's the medium doing there? How does the information behave?
Yeah.
The coordinates fix the algebra, not the physics.
Okay, let's shift gears a bit to the practical side of things. How GR survives in the real world. This is what we're calling the Newtonian borrow. GR often says Newtonian force is obsolete, yeah, but then it seems to quietly bring it back whenever actual calculations are needed.
Oh, absolutely. The Newtonian limit is, frankly, indispensable because GR's geometry on its own doesn't naturally handle forces or potentials in the way engineers or, say, atmospheric scientists really need for day-to-day work.
Where's the clearest place we see this happening?
Well, look at applied physics. Calculating atmospheric structure, for example, the standard formula, the barometric law describing pressure versus height. It absolutely relies on the old-school Newtonian gravitational potential and force GM over r squared to match what we observe.
So GR's geometry alone can't easily compute that local pressure relationship.
Not without huge computational effort. And even then, it struggles to give you that direct causal link engineers need.
So if you're plotting orbits, figuring out launch windows, calculating stress on a bridge, you're using Newton's forces and potentials, GR just adds a small correction on top.
Pretty much. Newton's the workhorse for that kind of causal accounting in practice. GR provides the refinement.
Okay.
It really highlights the difference between a high-level description and a mid-level causal explanation.
Yeah.
And this leads directly into the next survival tactic, the frame partition.
This is where you have conflicting physical descriptions,
Right.
but they're declared okay because they exist in different frames of reference.
Yep.
Sort of avoids making them consistent.
Exactly. Think about just jumping up and down. You, the same person, are described as force-free while you're falling.
Right.
But the instant your feet hit the floor, suddenly you feel a force. GR doesn't really connect those two states smoothly. It just partitions the story. One frame for the fall, a different frame for the impact.
Instead of giving a continuous explanation, like how the force builds up.
Precisely. It avoids needing that single, medium-level causal chain. The conflict is just blamed on your viewpoint changing, not on a gap in the physics itself.
It's like the ultimate not my department move in physics.
Okay, shifting focus again, from these local practical issues to the deeper theoretical foundations. The next strategy is a big one, treating mathematical description as mechanism. This is where, if the geometry fits the data, that fit becomes the explanation.
It's a classic line we always hear. Matter follows geodesics.
And that's the core of the issue right there, that statement. It's purely descriptive. It tells you what path matter takes through this curved space-time.
And not why.
Exactly. It doesn't explain why the path bends without some kind of actual physical push or interaction. There's no causal agent identified. It's just a rule about the path, mistaken for the reason for the path.
And we see this with things like gravitational redshift and time dilation too, right? The math, the metric, it gives you the factors. Clocks slow down, light stretches. The numbers work out perfectly.
The numbers work beautifully. But the crucial physical question is just left hanging. What is physically slowing down the internal ticks of an atom or a clock? What interaction is causing that delay in a gravitational field? The geometry gives you the how much, but not the how.
This reliance on the math, the form over the function, leads us to another tactic. Elegance as authority.
Right. The main field equation, G mu nu equals T mu nu, it's mathematically gorgeous. It connects space-time geometry to the energy and momentum of matter. It's elegant.
Yeah, I can see why physicists love it. But you're saying that beauty itself kind of acts as a substitute for a physical explanation.
I think it often does, yeah. The sheer elegance of that relationship can distract from the missing causal links. The equation itself doesn't explain how matter actually causes the curvature.
Like what carries that influence?
Exactly. Or how the resulting curvature then causes motion. The mathematical beauty sort of becomes its own authority, stopping deeper questions about the actual mechanics or the carrier.
And tied into this is maybe the final philosophical block, elevating the equivalence principle.
The equivalence principle. It's that observation that locally, feeling acceleration in a rocket ship is indistinguishable from feeling gravity on Earth.
Okay.
GR takes this local similarity and elevates it into this overarching philosophy. It basically says, see, mechanism isn't even necessary to describe this.
So instead of being a clue, pointing towards finding an underlying mechanism like how thermodynamics pointed towards atoms moving, it's used as a reason to stop looking.
Kinda, yeah. GR defines itself as a principal theory based on this equivalence, which then conveniently shields it from awkward questions about what is carrying the gravitational influence.
Okay, so we've covered local fixes and theoretical justifications. Now, let's get into the third big category, the sort of patchwork of fixes, starting with maybe the biggest logical hole, the vacuum contradiction.
Right, we say space is empty, a vacuum, yet we allow energy to travel through it as waves. Think about light electromagnetic waves. They diffract, they interfere classic behaviors, suggesting they're moving through something, a medium.
But the official story is still no medium.
Emphatically. No medium. And it gets even more awkward with gravitational waves. They definitely carry energy. They make detectors move. But because there's officially no physical stuff for this energy to live in locally, GR needs these things called non-covariant pseudotensors just to do the energy bookkeeping.
A pseudotensor? That sounds like a fudge factor.
Essentially that, yeah. It means you can't rigorously define the energy density of the gravitational field in one specific spot, the way you can with, say, electric fields. The energy is real, the wave deposits it, but it's hard to pin down where it is along the way, physically. It's slippery.
And this patching continues with maybe the most famous examples, balancing the books with the invisible.
Ah, yes. Dark matter and dark energy.
Mm-hmm.
This is where the framework is kept intact by just adding things we can't directly see or detect, purely to make the equations match observations.
So dark matter gets added to explain why galaxies rotate faster than their visible matter suggests they should.
Exactly. But then, doesn't this create a kind of circular argument? Well, we often use general relativity itself, specifically how it predicts gravity should bend light. Strong lensing to map out where this invisible dark matter must be.
Ah, I see. You assume GR is right to find the dark matter.
And then you point to the existence of that dark matter map as proof that GR is right. It can become quite self-confirming.
Okay. And then there's dark energy, the lambda term,
Okay.
right? Added to explain why the universe's expansion is accelerating.
Yep. We're literally sticking a Greek letter, lambda, into the field equations just to make the cosmological numbers fit the supernova data. It balances the mathematical book, sure, but it's just a placeholder.
No mechanism provided for what's causing this negative pressure or vacuum energy.
None whatsoever. The equation just needs that number to work out. The y is completely missing.
And finally, in this category, GR seems to deploy a strategy of policing the boundaries, basically managing paradoxes instead of actually solving them.
That's a good way to put it. Take the information loss paradox with black holes. The idea that information about what falls in might just vanish forever, that's a huge conceptual problem for physics.
So instead of finding a physical way for information to get out,
We invent new concepts like complementarity or firewalls, essentially theoretical patches designed to forbid the information loss, but without really fixing the underlying physical transport problem. It's paradox management.
and if the equations happen to allow weird stuff like time travel, closed, time-like curves,
Oh, those solutions are just declared unphysical, ruled out by decree, like chronology protection. The math might allow it, but the theory says nope, just because.
and crucially, to avoid clashing too much with quantum mechanics, there's the strategy of splitting the world into domains.
Right. GR gets the big stuff, cosmology, gravity. QM gets the small stuff, particles, forces. Keep them separate.
Which conveniently lets everyone sidestep that really thorny question. How does a quantum object, which can be in multiple places at once, curve a single classical space-time metric?
Exactly. You just fence off the problem areas, postpone the inevitable conflict between the two theories.
Okay, listening to all this, the through line seems pretty clear now. These 9 different strategies, the coordinate tricks, borrowing Newton, the dark placeholders, managing paradoxes, they all seem necessary because GR, at its heart, is this powerful descriptive geometry that just lacks a physical causal mechanism for gravity itself.
And that brings us directly to the radical alternative proposed in the source material, graviton pressure theory, or GPT. The remedy it suggests is actually quite simple, but profound. Put the medium back. Put the cause back.
So the idea here is that space isn't empty after all. It's actually, what, a field of gravitons that has density and pressure.
Exactly. A self-repulsive graviton field. And motion then isn't some mysterious path through geometry. It happens simply because pressure gradients in this field push things around.
And this approach, it claims to resolve the issues GR needs all those tactics for.
That's the core claim. It aims to mechanistically solve the problems GR manages. Let's contrast it directly. Remember GR's upward accelerating ground trick for weight?
Yeah, the expanding Earth thing?
GPT just says weight is blocked inflow. The graviton medium is flowing inwards, you block it with your feet, and that creates a real physical contact pressure pushing you up. Simple. And free fall. That's just unopposed inflow, nothing blocking the push from below.
Okay, that sounds more intuitive. What about time dilation? GR uses that geometric factor.
GPT suggests it's mechanical fatigue. Imagine a clock's internal mechanism, like an atom oscillating. If it's sitting in a region with higher graviton pressure or more intense inflow,
It gets jostled more.
sort of, that increased encounter rate with gravitons could interfere with or drain energy from the internal cycles, literally slowing them down.
Right.
It provides a physical why for the clock running slower.
And singularities, black hole centers.
GPT suggests the graviton field itself isn't infinitely compressible. There's a limit. So true singularities become physically impossible. What we call an event horizon might be more like a very dense pressure layer.
A layer that could maybe echo or leak information, avoiding the paradox.
Potentially, yes. It provides a physical boundary with actual properties rather than a mathematical point of infinite density. It opens up channels for information transfer that DR struggles with.
And does this help with the invisible stuff, dark matter?
The claim is yes. For galaxy rotation curves, for instance, GPT suggests the pressure gradients within the dense graviton field itself could provide the extra stabilization needed without requiring vast halos of unseen matter. The pressure dynamics replace the need for dark matter.
So the whole picture shifts from this complex structure of management tactics and patches.
Down to potentially a single, consistent energy system driven by local pressure gradients. Pressure, denoted as P.
GPT isn't managing the paradoxes GR creates.
It's trying to remove the assumptions like the empty vacuum, the lack of a physical force carrier that led to the paradoxes in the first place. So wrapping up this deep dive, it's been fascinating. General Relativity's success, its endurance, it's undeniable, its predictive power is spectacular. But as we've seen, that endurance seems heavily reliant on this complex toolkit of intellectual practices.
Yeah, the reframing, borrowing from Newton, adding invisibles, relying on mathematical beauty.
Right. These have effectively insulated it from needing a decisive causal mechanism. A powerful descriptive geometry seems to have become an accepted substitute for a fully physical theory.
Which leaves us and you with a final thought to chew on. If all these scattered successes of GR, all these phenomena it describes, could potentially be lined up as just shadows cast by a single continuous physical cause,
Like pressure from a medium.
then what are we really prioritizing when we choose the complexity, these 9 or more intricate survival strategies, the exceptions, the patches over the potential simplicity of causality, over just having a single continuous pressure-driven medium doing the work?
The fundamental question becomes, why would a complex management structure, even one that's mathematically successful, be inherently better than a potentially simpler mechanistic explanation?
Maybe the most powerful thing we can do is just keep asking the simple question. How do things actually move? Not just what mathematical path they follow. Something to think about.